Moving into 5.6, we already talked about what it takes to find your zeros, how many zeros. Now we're going to get into the fact of how do we actually find them and prove them. So when you look at something like this, the first thing you should do is look for the highest exponent. That is your total number of zeros. So since this has an exponent of 4, I know my total zeros, I'm just going to put t, is 4. Then I'm going to graph it. So you're going to go to your calculator, you're going to go to y equals, and you're going to put in your full polynomial. Make sure you type it correctly because obviously if you mess something up, it's not going to look the way it's supposed to. So 2x to the third, 1913x squared plus 10x. And I'm going to hit graph. And I'm going to count how many times it crosses or touches the x-axis. And actually what you see on this one is it touches the x-axis 4 times. There are 4 times that it crosses through. It looks like it happens once around -5, looks like it happens around 0, looks like it happens at 1, and it looks like it happens at 2. So I'm going to make a little list over here. If 4 times it crosses the axis, and I knew there were 4 zeros, that means all 4 of my zeros are real, meaning there are none left to be imaginary. So I'm going to make just kind of a little checklist off to the side when I start these. Now, the first thing I noticed with this one is every single term has an x. So I'm actually going to factor an x out, which leaves me with x to the third plus 2x squared minus 13x plus 10. That will give me one of my zeros, is that 0 is a 0. The rest of them, I'm going to rely on the picture and synthetic division. So it looks like it crosses the x-axis at 1, and it looks like it crosses it at 2. So I'm going to go to my problem. I'm going to write my coefficients, 1, 2, -13, and 10. And I'm going to see what happens when I put 1 in. I know I should get a 0 remainder if I did it correctly. So I drop down, multiply, add, multiply, add, multiply, add. At this point, I've now proven that 1 is a 0. Now you have choices. You can either continue the process of synthetic division if you can look on the graph and say, hey, I see some other really good ones. When I say really good ones, like integer values, or you can stop and start factoring. And you really have a lot of choices. I'm going to factor this one just because I really like to factor. So when I write down what I have left, I have 1x squared plus 3x minus 10. This factors x plus 5, x minus 2. It's a basic FOIL factor. So I get my other solutions to be -5, which I saw on the graph, and +2. So all of my solutions, I said there were 4 of them, I've got them all. 0 I got at the beginning, 1 I got from synthetic, and -5 and 2 I got from doing factoring. Or I could have done more synthetic. So this one, my total number of zeros is 3 because that's the highest exponent. So then I'm going to go to my calculator. I'm going to get rid of this. I'm going to graph x to the third plus x squared minus x plus 15. And I'm going to take a look at it. And what I see is it only crosses the x-axis 1 time. What that means is since there were 3 zeros, one of them is real and the other 2 must be imaginary. Now keep in mind, imaginary always come in pairs. So you can only have an even number of imaginary solutions. It's possible to have 2, it's possible to have 4, it's possible to have none. It's not possible to have one imaginary. That's just will never happen. So now to prove that one solution, let me go back to my picture. It looks like it happens at -3. So I'm going to set up my synthetic division, 1, 1, -1, and 15. And I'm going to put where it looks like it crosses, which is -3 outside. Drop down, multiply, add, multiply, add, multiply, add. And because I got a 0 remainder, that proves that -3 is a solution. Now, if you're wondering about what's left, we're left with an x squared minus 2x plus 5. That's where the imaginary comes in. 2 imaginary, 2 because it's a power of 2. That is the part that you'll never actually see on your graph. All right, next one. This one's really long. However, it will work out really nicely on a calculator. So this one has a degree 5, which means my total number of zeros should be 5 of them. So I'm going to have x to the 5th, just takes a while to type in, minus x to the 4th, minus 3x to the 3rd, plus 3x squared. This is definitely one you want to make sure you type in right because there's so many terms, plus 4x, minus 4x, excuse me, plus 4, graph. 1, 2, 3. And that's it. So this means that since I know that I have a total number of zeros of 5 and it crosses 3 times, that means the other 2 must be imaginary. So I make my little list off to the side. 5 total, 3 real, 2 imaginary. So now let's prove the real ones. So if I go to my calculator, it looks like it crosses at -2, at +2, and at 1. So -2, +2, and 1. So let's go through and prove all those. So 1, -1, -3, 3, -4, 4. Let's start with 2. So I'm going to drop down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. And we did it. We proved that 2 was a solution. Now let's try -2. Drop down, multiply, add, multiply, add, multiply, add. When the numbers are small, sometimes I get mixed up, so try and take your time. That worked. And the last one, let me go back to my picture, was 1. So I'm going to put a 1 out here. 1, multiply, add, multiply, add, multiply, add. So I get solutions of negative and +2 and +1. And again, if you're wondering what's left, what does this mean down here? Well, if I divided 3 times and I started out with x to the 5th, then what I'm left with is I'm left with an x squared, no x's, and a 1. And we've talked about before that does not factor, and it gives us our imaginary. So that's where the imaginary comes from. It comes from that piece. This one, again, my total zeros are 4. I'm going to graph it to see what I can see as far as real zeros. So 2x to the 4th minus 3x to the 3rd minus x minus 6. Graph. 1, 2. And that is it. Should not surprise you that you're not going to see it again because it is an even function because it has an even degree and it's going up on both sides, which is what I expect. So this one has 2 real, 2 imaginary. My real look to happen at -1 and +2. So I'm going to set up my division. I am going to need a placeholder here. I have 2x to the 4th, -3x cubed. I have no x squareds. I have -1x, and I have -6. So I'm going to start with -1. Drop down, multiply, add, multiply, add, multiply, add, multiply, add. Again, that works. And then I'm going to try 2 because that was the other place that it looks like it crosses the x-axis. So I'm going to drop down, multiply, add, multiply, add, multiply, add. So I have proven my 2 real ones are at -1 and at 2. And what I'm left with, my 2x squared minus x plus 3, that's where the imaginary comes from. That is the part that's not factorable, that doesn't give any real solutions. So let's look at one that we don't have as much opportunity to do the synthetic division. So this one has a degree 4, so my total zeros should be 4. When I graph it, move it over here so you can see a little better. So y equals x to the 4th plus 6x squared minus 27. So just like the last one, it has 2 places where it crosses. So it has 2 real and 2 imaginary. Here's the difference, though. The last one, it was very obvious where it crossed the x-axis. This one, it's not quite 2, and it's not quite -2. Like, if it goes exactly through the number, you would actually won't see that little hash mark, that little mark on the axis, because it will go right through it. And that's not happening here. So with that, I don't have a good number to do synthetic. If I actually tried 2 and -2, I would not get a 0 remainder. So I'm going to factor this and show you what happens. So I need to pick 2 numbers that multiply to get -27 and add to get 6. That's going to be 9 and -3. So when I break down an x to the 4th, it's going to be x squared plus 9 and x squared minus 3. Here's your imaginary part. X squared plus a number will not factor. Here's where you're going to get your real solutions. It will not go further because 3 is not a perfect square, but we could set this equal to 0, add 3 to both sides, and then take the square root. And anytime we take a square root, we call them pairs. We get plus and minus. Those are your 2 real solutions. And you'll notice if you actually took your calculator and figured out what is the square root of 3 equal to, the square root of 3 is almost 2. Negative square root of 3 is almost negative 2. So that's why your graph was almost going through at 2, but not quite. And you're going to have that when you have irrational solutions. And that's what this is. This is an irrational solution. It's not an integer solution. Let's talk about repetitious zeros. What happens when zeros repeat? So this one has a total number of zeros of 3. When I graph it, I'm going to get x to the third plus 6x squared. Oh, extra number there. Plus 12x plus 8. And we're going to hit graph. So this reviews something that we talked about earlier in the chapter, which is these multiple zeros. So if you have, I'm just going to draw like some little extra pictures here to explain this. If you have a situation where a graph touches an axis and bounces back, that is what is considered like a double zero. It's a double solution or a multiple solution of 2. If you have a graph that goes up and it like lays on the axis, which is actually what's happening in this picture, this is a triple zero, which means it actually counts as 3 of the zeros all rolled into 1. So if you go back and look at this, right on, let me kind of highlight it a little bit in case you're not seeing what I'm trying to say. Right here, your graph, instead of touching and bouncing back or going directly through, it kind of lays on the axis a little bit. What that means is that solution actually counts 3 times. So when I count my zeros, I'm going to say I have 3 real zeros, although they all happen to be the same number, and I have no imaginary because all 3 are real and they're all taken up by the same value. So if I go here and I start my synthetic, so 1, 6, 12, 8, when I do my synthetic, I'm going to do the number that it looks like it lays on, which is negative 2. I drop down, I multiply, I add, I multiply and add. You could now do synthetic 2 more times with the same number, or you can write down what you're left with. You're left with an x squared plus 4x plus 4. And when you factor that, 2 numbers that multiply get 4 and add get 4 are x plus 2. And you'll see you have that repeated solution again. So negative 2 makes this 0. It makes this 0. It also what we did up here. So the only unique solution is negative 2. It just happens to be a multiple solution show up 3 times. So the idea that if it touches the axis, it counts as 2 solutions. If it lays on the axis, it counts as 3 solutions. I wanted you to see that type of problem. So that gives you an idea, again, a little bit more explanation of 5.6, how we find zeros, how we use our calculator, the total, the real, the imaginary, all coming from the graph, and then doing synthetic, division, and factoring to prove.